This is a program that controls the gripper, and instead of using, for example, duty cycle or distance or something, it uses the angle of the servo motor to control the gripper. And I'm not going to go over this in as much detail because I've got the detail in the other videos, so let me go over this quickly. But in case you need to use angles rather than distance or duty cycle, then this is the answer for you. This is Python 3. It's set up to work with a Tower Pro MG995 servo or equivalent. There's a lot of these out there that are equivalent. I have built this to run multiple grippers. So the first gripper is gripper A. Pin 2 is 5 volts, pin 6 is ground, and pin 40 is the PWM control. We're going to import GPIO library, we're going to import the time library so we can use sleep, and sleep is important. GPIO set mode to board, GPIO setup. We're going to use pin 40 for the control as we set up here, and we're going to change it to an output. Now we're going to do this PWMA. We're going to create a command that is GPIO.PWM 40 and 50 Hertz, pin 40, 50 Hertz. PWM is a function in the Raspberry Pi software in the Debian operating system. We are going to take this and we're going to feed this command, if you will, start position of 0. And what that's going to do is 0 is neutral. It's no data is being sent. Let's scroll down and get to the real software. Okay, the main part of the program is down here, and all I've done is I'm going to loop through it 7 times. You can do whatever you want. You can put up a while loop or whatever and have it loop forever. But so I just set up a loop here, and the first thing is to ask the user what angle they want to input. So it goes from 0 to 180, or whatever your servo will do. And then what we're going to do is we're going to use this variable to call our calculation function up here. And this is going to take our angle and it's going to turn it into motion in the servo. Okay, so I called it grip angle A. We're going to feed it the angle from the user. We're going to compute the duty cycle, which is how the servo actually moves. We're going to compute that based on the angle divided by 18 plus 2. This formula is based on the servo, so whatever your servo is, use that correct formula. Then we are going to do an output to pin 40 on true, so we're going to turn pin 40 on. Then we're going to change the duty cycle based on this number that we got from this calculation. And then we're going to sleep for about half a second, and that'll give the servo time to move, because the computer operates much faster than the servo. So we have to give the servo time to move, and we're going to give it half a second, which is about the best I have found. Then GPIO output 40, we're going to turn that back off, and then we're going to change the duty cycle to 0, which will stop data going out on that pin. Some servos like to vibrate, so these kind of things will help prevent that vibration. Okay, so we called that from here, it comes back, and it'll do this loop 7 times. When it's done, it will fall through. I'll turn off the PWM, do the GPIO cleanup, and then print done. So, does this program work? Okay, well, let's start it up and run it. I will hold the gripper up here, mostly out of the way. And, well, let's see, what should we give it for an angle? How about 0? And yes, it closes. Let's say 170. That's maximum open. 56, like that. So the angle I'm giving it is the angle of this arm of the servo, and that's controlling the opening on the gripper. Okay, so that's how you control your robotic gripper using angles rather than, say, direct duty cycles or some other. Okay? Hope you found it useful and interesting in your Raspberry Pi robotics experimentation.